Dear students, in this lecture, we will discuss about couple. First, the definition of couple. Couple is a set of two equal and opposite forces acting along different lines of action on the same body. For example, here is a table and we want to rotate this table about point O. For this, student A will apply force in the south direction and student B will apply force in the north direction. But please remember, both forces must be of same magnitude. But as you can see, they are operating in opposite directions to each other. It means they are anti-parallel to each others. And both are acting along different lines of action. This force has line of action in this direction, and this force has line of action in this way. Now, let's take an example of a steering wheel of a car, as you can see in this figure. When two opposite movements acting to cause an object to rotate, such as we already discussed in table case, now we want to discuss by taking the example of steering wheel. And when we want to turn the car, we apply forces at two different places on the steering wheel, and that we are doing by using our hands. Left hand is at this point applying the force. When we apply the force in the north, for example, in upward direction, and second hand, right hand, applying the force F in the downward direction, but this force must have the same magnitude as the force applying by the left hand. Now the question is, what is the moment of a couple? That can be calculated by simply multiplying the size of one of the force acting on the steering wheel. We want to multiply with the perpendicular distance between two forces, and that perpendicular distance is from this point up to this point, and that is represented by D. So moment of couple equals to F and to D, and this F is the magnitude of one of the force, and D is the perpendicular distance between both forces. Now the question is, what is the torque as a result of by these forces? And that is can be exactly finding by the formula torque equals R cross F. And this R cross F is nothing but R representing the perpendicular distance between both forces, and that, as I already discussed, is representing by D in this case, and F is nothing but the magnitude of one of the forces applying at two different places on the steering wheel. So this is how we can find the moment of it. We can find the torque. Now the question is, what is the net torque from clockwise and anti-clockwise movements acting on the body at some arbitrary point of rotation? To understand or to calculate the net torque, let's have a look at this wood plug example, which is hanging at point P, and we want to rotate it by applying opposite forces at the ends of this wooden plug. One force if we want to apply at the left hand, and that force is in upward direction, and the second force we want to apply at the right hand, and the force which we want to apply that is downward direction, and there is a perpendicular distance of D between both forces. Now the total torque of a couple in this case can be easily found, and that is simply torque equals F into D half. D half means this is the distance of force of this force, upward force, from pivot point. So this is D half. So the torque would be F into D half plus, this is the second part of the torque, which comes from this force F, and this force is in the downward direction, and but at the same distance from the pivot point, and that is D half. So this sums up with the earlier torque, both comes up with the total result of Ft. So total torque of a couple equals Ft. Now question is, if we move the pivot point from the center, now what would happen with the total torque of a couple? Let's have a look this calculation. In the case when pivot point is not exactly at the center of the wood plug, tau equals Fx, and this x is the distance of this upward force from the pivot point, and plus F into d minus x, and d minus x is the distance of this downward force from the pivot point. Now to simplify this equation, we get tau equals Fd. This torque exactly equals to the earlier torque. The earlier torque was the case when the pivot point was at the center of the wood plug. So this means the total movement is always same regardless of pivot point.